We're next going to look at the cut feature that creates these three cut windows through the wheel blank. And to do this, we're going to use 3-point arcs and a couple of endpoint constraints to make sure that this shape matches up with the existing geometry. When we cut through it, we're going to use a through-all pattern, cut depth, and we're finally going to create a circular pattern around the central axis so that we only have to draw one shape. So before we go into SolidWorks, I just want to take a note of the sketch limitations here, or sorry, the constraints. So we've got an angle between these points, these outer points, and the center axis of 53.87 degrees, which is kind of an odd way to specify it, but it will restrict the width of this gap here. Similarly, we've got this radius of these two independent arcs, each one being 4.35. So a combination of the symmetry about this center axis, this angle, and those radii will determine entirely that shape. Okay, so switching over to SolidWorks, we'll start by creating a sketch using the extruded cut tool, and we're going to place that on the wheel surface here. And for our first step, just create a vertical center line, which we can snap to vertical. And then we can use a couple of quick and easy ways to get reference geometry. If we wanted to, we could create a center line version of this circle. We could use convert entities, and this edge here would become for construction. Hit check, and now we have a nice construction circle. Also, you can just draw directly on that edge as well. I'm going to use a few center point arcs here, or sorry, 3-point arcs, not center point, to illustrate that right now. So I can, if I hover my mouse over this outer rim here, I can create a starting point directly constrained to that edge. Similarly, I can constrain to this bottom edge here, and then with my third point, create an arc that looks approximately like the shape that I want. I can do the same over here, and if I wanted to, I could even constrain this line directly, so both this line and the circle at the same time. So another time saver, let's say I've done that and I have this one arc. I can get that symmetry constraint for free by using mirror entities. I'm going to mirror arc 6, and I'm going to mirror it about this center line. So now, basically, I get this arc with the same radius and all the appropriate symmetry constraints, so that when I go to drag this around, the parts move together. Okay, so at this point, we have these parts coincident. We want to draw a 3-point arc along the top here that connects these guys. And we want to start applying our constraints to match these up. So we know that these are the same radius, and this is going to be 8 point, I'll just flip back to the drawing to check, 4.35. 4.35. And now we can see that this is sort of reaching the shape that we want. I'm then going to add an angle constraint, and we do that by selecting the center point first, then one edge, or sorry, one point, and then the other to create the angle. I place it with the left mouse button and then specify, let's see, that would be 53.87. So we've got 3.87. And then, last but not least, we want to have this arc and that arc be coincident. You could also make them equal radius. And now our sketch is completely specified, and we can accept those settings. We then want to do through all. You can also do through next. Hit accept to make the cut, and now we have one of the 3 cuts completed. We can see it perfectly intersects with this surface, so we've achieved that that match of geometry there. So we've created, sorry, we don't want a linear pattern. We've created this cut. Now we want to do circular pattern. So with this selected, we see that it populates features to pattern And we just want to pattern this one guy for now. And we're going to select a convenient circular edge nearby to create a set of patterns. A set of items in this pattern along this axis. We want to specify 3 items, hit check, and now we have the basic cutout. The next step is going to be to create these cutouts shown in darker green. And these are not through cuts, but they're cut in a little bit so that the central web, the thickness of this part in green, is going to be 0.2 inches. And we're going to do that by offsetting from the center plane by 0.1 inch. Otherwise, it's basically the same procedure on the feature end, but we're going to use some clever tools such as offset to simplify our lives here. So, to create a sketch here, we're going to do the same thing, extruded cut, sketch on this plane, and we'll start with a center line once again, snap to vertical. And one of the first things I'd like to do is lay out a center line along here, which we know from our drawing is going to be an angle of it's going to be an angle of 60 degrees away from this vertical one. So this will be the center axis of our new pattern. And at this point, I want to show you how to quickly acquire geometry. You can see this highlighted shape. We can make that into a sketch entity using either the convert entities or offset entities function. For now, we're going to use offset entities. And to do this, we want to specify a dimension that for now doesn't really matter. I want to click reverse so that it goes to the inside of the sketch. And then hit accept, and now you can see we have this fully constrained offset version of this outside surface. So because this constraint doesn't quite match, I'm going to delete that constraint, the dimension, and free that up. So in a sense, it's not quite an offset that we're using because we're changing the dimensions, but it's a quick way to create this geometry. So based on our drawing here, we can see that the thicknesses aren't exactly the same, and that's because we have the dimensions are constrained instead by these angles here. So we're going to create those now. We're going to start with the inner angle, again starting from the center, the first point and the second point. So instead of 90 degrees, we want that is 62.5. 62.5. And yes, we can see this is kind of off center, which we'll fix that pretty soon. And then, so in our smart dimension, we'll again start from the center, first, second point. And this angle is going to be 56.5. Okay. And now, at this point, we can quickly apply a mirror constraint, or sorry, a symmetry constraint by clicking the 2 points and the center line. And we want the same for this guy as well. And finally, we're going to add a radius constraint on here, which we can see here we've got 3 radii of 8.2. So we'll say 8.2. Now let's take a look at what's still free. So we know at this point there's a couple of constraints that we want to apply to keep the shape preserved. We can see that even though our outer dimensional constraints are there, we can still drag these inside arcs and kind of change the shape. So what we're going to do is apply concentric constraints between these outer arcs, because remember, they're supposed to be offset. Oops, it appears we've over-defined the sketch there, so we'll just back out for a second. Sorry, we'll delete that second constraint, make this concentric. So again, we don't need a duplicate symmetric constraint at the top and bottom, but we do want to make these arcs concentric. And same goes for the others as well. We want to make those concentric and this concentric to this guy. once the appropriate geometry constraints are formed, we can see that with symmetry around the central axis, we have a completely defined section that we can use to cut. We then accept that sketch. This is now an offset from surface cut, which is different from the blind cut. And I'm going to offset this to the right plane here. So you can see that's the center plane that slices through the middle of this. And we're going to offset 0.1 inches from that to allow this to leave a web of 0.2 inches in the middle. Hit accept. You can see that this goes in a little bit. And if I wanted to, I could mirror this about the right plane. And now you can see what it would look like on the other side. And you can see that in both cases, we leave this web in the middle. So, in this point, you can create the pattern, and it's somewhat arbitrary if you decide to pattern and then mirror versus mirror then pattern. I'm going to try the mirror then pattern now, but it should produce the same results overall. Here we have that pattern. You'll notice I've chosen both the cut and the mirror as features to pattern. I've chosen this outer edge as my cylindrical reference, and I've got, again, 3 elements. Hit check. And we can see that, uneventfully, we have all of those cuts made.